In this presentation, we will be looking at the supervision, management, and maintenance layer. And we just call it the supervision layer from this point on. So this is a third layer of code that will come on the top of the executive layer and the theory and hypothesis. And it's easy to explain and understand why we need this structure. I won't use many minutes for that. But it is something that involves significant amount of coding. The large portion of the actual code inside of the whole computational infrastructure will be dedicated to this layer. So why do we need this? First, when we begin developing the infrastructure, and we have some simple derivational search function and perhaps few grammatical operations and a set of lexical items that may be completely arbitrary. It's easy to understand what the model is doing. But as soon as we start working with real linguistic theories and hypotheses and real linguistic data, that's no longer the case. The system will simply become so complex very fast. And the amount of computations that it's going to be doing is so huge that we can't really easily control and understand the model. And the supervision layer is meant to allow us to take full control of what we are creating. So I'll just give you examples of how what this layer is going to do and why we need it. Now, one thing is that when you work with the real data and real linguistic hypotheses, and if the model doesn't behave as you expect it, if it does something unintentional, if it makes some errors, in some rare cases, and especially when you're working with extremely simple systems, it's possible to see from the out some kind of simple output what's going wrong. But as soon as the model gets more complex and more non-trivial, that's no longer the case. So you see that there is surprising, unexpected wrong output from your theory or on the model, but you will have no idea of why this is so. And you can't find these errors anymore just by thinking about the output itself. So to solve this problem, we need more control of the internal operation of the model. And one way we will solve this, and this will be part of the supervision layer, is that we develop a logging function which will record in a separate external file all the operations that the model is doing when it's running the executive functions. And then you can consult that information, that data, to find out where exactly it's going wrong. The data, that file will also contain the list of all the features that are inside of your lexical items, all the intermediate partial phrase structure solutions, all the computational assembly operations and their outputs and inputs, and everything you want will be written there so that you can debug and you can find if the error is in your hypothesis, in the empirical part, that it will be easier to find it. So that kind of thing is part of the supervision layer. Another thing that we will obviously be needing is how do we check if the model is correct against the data. So in a very simple examples, you can just manually see that what the model is producing is what you want it to do. If you have few examples, only it's easy to check. But what if you have 1,000 expressions? It's not possible to manually test it, check the output. And not only is it impossible, but it's very unreliable. And remember that you will have to do this checking many times because your model is not going to be perfect after the first trial and error experiment. So you will have to fix the model and run everything again. So we need something that does this checking automatically. What does it mean? It means that there has to be some source code which is able to read your data set. It puts the data into some type of data structure, and then the output of the model will be put into a data structure, and then there will be code which is comparing the two automatically and has to be reliable also. That will be part of the supervision layer. And this gets quite interesting and non-trivial when we are talking, for example, not just verifying that the list of sentences is correct, but also that some semantic properties are predicted correctly, interpretations. So how would we do that? Well, I'm now contemplating that I I will have a third part for this presentation where I specifically talk about how to automatically check the correctness of this type of more abstract attributes like semantic interpretations. Then I should also mention that if you go back to the methodological principle I mentioned in the presentation, in the second presentation, the requirement was that it's not sufficient if the model calculates the data, and we have to show also that that's the case. And the supervision layer will be used for this purpose. That when we were recording all the steps that the model is executing in connection with some data set, we will also record all the errors and all the data comparisons into that file. So in effect, that derivational log file, as I will be calling it, will be the proof, the actual demonstration that I can share with anybody to show what the model is doing and that is deriving correct results. And at some point, when the input data becomes complex, the amount of calculations will be in the range of millions or hundreds of millions. And what will inevitably eventually happen is that this derivational log file becomes too massive, even for, it becomes very complicated for humans to parse. So for this purpose, the supervision layer usually, at least in my own research, it contains several other logging information that gives us more simple information. It reduces the details so that I can see more easily what's happening. And they can be more selective, so that I can have, for example, one log file which is specialized in semantic output, semantic raw data, and then another which is specialized for syntactic derivations. So we will actually, running the executive function will create typically, and in the end, several type of raw output data all going into separate files. And this will help us manage, maintain, and supervise the model, and also create these permanent records that we can use as some kind of permanent proofs or records of what the model did. And then the supervision and maintenance and management layer also contains all the issues that have to do with version control. I'm using Git for this. Most software developers today use that system, so it's very easy to implement. But the Git is a way where we trace the development of the computational infrastructure, and it allows us to return to a previous points also. So if we want to replicate from some study, we can create a separate version that is used to calculate the actual output that is reported in the scientific literature. And then we can store that branch as an individual permanent version of the whole package, so that anybody can replicate the same study by downloading that specific version of the software. So that's also part of the supervision, management, and maintenance, but that's something that we don't need to really to write our own code. We will just have to set up the system so that it's part of the whole computational infrastructure. So that was a simple description of what this supervision, management, and maintenance layer is about. As I already pointed out, it's a simple thing to understand. It's necessary to have it, but it requires quite a lot of coding and source code. I forgot just to mention one thing which you might consider. The human mind is quite efficient in encoding and understanding visual information. And so I have for that purpose created also a graphical user interface which allows me to visualize the outputs of the model, for example, the phrase structures as they are created. And in that system I can also scroll back and forward in time to see how the derivation evolves. And another thing for which I'm using this graphical user interface is that allows us, when I have a phrase structure on the screen coming out of my model, I can put the mouse cursor on the elements on it and see more detailed information about them. So what type of features were involved, what kind of calculations my model is doing with those items and other things. And that's very easy for humans to use this visual format. It's much more easier than browsing gigabytes of text generated by the model when it was doing the actual derivation. So the graphical user interface is one part of the supervision layer, and there will be a separate presentation, brief presentation of that component also. In the part 2 of this presentation, I will be looking at the implementation. This is so large topic that I can't look at it all, but I will be show some of the essential things that you always need very fast when the complexity of the model increases. The data handling and the logging, for example. And then in the part 3, I'm planning at least now that I will show how we can supervise semantic computations and verify that the model is correct when it comes to things that are involved in semantic interpretation.